So very good afternoon. Good afternoon, everyone. Welcome you all for NTA lecture. So in the last lecture, we have completed the constant K-type band stop filter. We have designed also the constant K-type band pass filter and band stop filter. Both we have designed. After that, we have started the M-derived filter. So in the M-derived filter, we have discussed about the what do you mean by M-derived filter, what are the disadvantage we are or drawbacks we are getting from the constant K type, and to overcome that, we are going to design the M-derived filter. So for that, we have to make some modification in the constant K type filter. Okay, so what are the modification in the T section and pi section we are going to discuss. So in the T section, we have discussed yesterday only. So there will be the modification in the series arm, that is m factor is multiplied. The value of m is nothing but scaling, we can say. So the value of m is greater than 0 and less than 1. So those points we have discussed. And after that, there will be the change in shunt arm. So shunt arm value is Z2 actually in the case of constant K type, but in case of M derived filter, it is Z2 dash. Okay, for the T section. So what is the Z2 dash? Z2 dash is nothing but the series connection of two impedances. One is the Z2 by M and second one is Z1 by 4M into 1 minus M square. So that is already we have discussed in the previous lecture. Okay, so I will show that what we have discussed in the previous lecture related to M derived filter. So before that, we have discussed about the summary, how to remember all those formulas. Okay, so I will share this. So this summary we have discussed, summary of constant K type filters. So to design the constant low pass filter, we have to use two formulas L and C. L is equal to K by pi FC and C is equal to 1 upon K pi FC. So based on these two formulas as considered as a basic, you can remember all remaining formulas related to high pass filter, band pass filter, and band stop filter. So logic already I have discussed in the previous lecture. So after that, we have started the M derived filters. So we are getting the attenuation low in case of stop band. So to increase up to that 100%, we are making really equal to ideal filter. So for that, how to increase the attenuation in the stop band? By adding the ladder session in the T section or pi section. So if we are adding the ladder session, then automatically there will be the increase in attenuation in stop band. Okay, and also in case of constant K type, there will not be a uniform characteristics impedance at all frequencies. It is changing for some frequencies. So to remain that value Z0 constant, also we are making modification in the constant K type. So if a constant K type filter considered as prototype, and then it is designed, it is possible to design a filter which have more attenuation in stop band, that is 100% we are trying to make, and say we are keeping the characteristics impedance same or equal at all frequencies. So if you are doing this, then that filter is converted into modified or M derived filter. So that we are going to discuss in this chapter. So consider the T section first of all. So this is the T section constant K type filter, and this is the M derived T section filter. Okay, so there will be the modification in the series of M factor is multiplied, and in the shunt arm Z2 is replaced by Z2 dash. Okay, so by considering the characteristics impedance with respect to constant K type and with respect to M derived filter, it should be equal. There will not be change. Okay, so for that we have taken the formula of Z0 T and Z0 T dash. So we have derived this the value of Z2 dash. So Z2 dash is nothing but the what you can say addition of two impedances Z1 into 1 minus M square divided by 4M and Z2 by M. So that we have added in the shunt arm. So that is shown. So this is what T section M derived filter. So up to this point, we have discussed in the previous lecture. So we can discuss now the pi section M derived filter. Pi section M derived filter now. If any questions will be there, you can ask. Otherwise, we can start the today's point. Okay, so we can start now. The M derived or pi section we can consider. Pi section M derived, pi section M derived filter. So again, there is a derivation for obtaining what will be the change in the diagram. So first of all, I will draw the diagram of pi section with respect to constant K type. So here it is Z1 as it is. Okay, so here it is 2Z2. Here it is 2Z2. So this is what the pi section. This is what pi section of constant K type filter. Now next, we are making changes here in the M derived filter. So Z1 is replaced by Z1 dash. Z1 is replaced by Z1 dash. Z1 dash value we have to find out. And with respect to shunt arm in the pi section, it becomes 2Z2 divided by M. 2Z2 divided by M. Okay, so M factor is divided here for the shunt arm. So this is what pi section of M derived filter. Okay, now again there will be the derivation. So derivation is that much not important, but I will tell what will be the value of Z0, sorry, Z1 dash. Okay, so Z1 dash, I will tell the value directly. So the value of Z1 dash will be Z1 dash. There is a derivation, but not asked here. Z1 dash is equal to Z1, sorry, M into Z1, MZ1 into bracket 4M Z2 divided by 4M Z2 divided by 1 minus M square. M Z1 into 4M Z2 divided by 1 minus M square divided by M Z1 plus 4M Z2 divided by 1 minus M square. So anyone can tell what is the meaning of this one? So it's look like ZT is equal to Z1 into Z1 parallel Z2 or some R1 parallel R2 you can compare. RT is equal to R1 parallel R2. So this is one part and this is another part. here multiplied in the numerator, and here in the denominator it is added. Okay, so what do you mean by this? How many impedances are connected in parallel here? How many impedances?
2 impedances.
Yes. So the pi section of M derived filter, the pi section of M derived filter consists of parallel combination of, underline, parallel combination of two impedances MZ1 and 4mZ2 divided by 1 minus m square in series arm. Because Z1 dash is in series arm. So Z1 dash is equal to two impedances MZ1 and 4mZ2 by 1 minus m square. These two impedances are connected in parallel with each other. So I will draw now the M derived pi section with the modification. So modification also I will draw here. So there will be two impedances connected parallel with each other in the M derived pi section. Okay, so this is what M derived pi section filter. So value will be what? Here it remains 2Z2 divided by M. 2Z2 divided by M. But what about these values? So it is MZ1, sorry, MZ1, correct, MZ1, and this is 4mZ2 divided by 1 minus m square. These two impedances are combinedly called as what? Z1 dash. Okay, so Z1 dash is nothing but MZ1 is in parallel with 4mZ2 divided by 1 minus m square. So this is about what? The pi section of M derived filter. So where should be the modification? So modification in the series arm. Instead of Z1, you have to choose as a Z1 dash, where Z1 dash is nothing but MZ1 is in parallel with 4mZ2 divided by 1 minus m square. So if any questions will be there, we can ask. Otherwise, we can start the M derived low pass filter. So today we have to complete the low pass filter. M derived low pass filter. Any questions? You can take 30 seconds. You can read it, everyone. Another question, Syed? Yes or no?
No,
Please
sir.
reply. Only one student. What about others? 144, 114 are there total. Okay. Now the next topic we can discuss the M derived low pass filter. Next point will be M derived low pass filter. There are the two M-derived filters we are going to discuss in this chapter: M-derived low-pass filter and M-derived high-pass filter. So we can start from M-derived low-pass filter. So up to now, what we discuss about M-derived? So introduction part. After that, T section and pi section. What will be the modification in the T section and pi section with compared to constant K type? So M-derived low-pass filter. We are going to start now. So M-derived low-pass filter, first of all, I will draw the diagram. Okay, and then we can start for the discussion. So in low-pass filter, in the series arm, inductor is there or capacitor is there? I'm talking about T section. Which element is there in the series arm? Inductor or capacitor or both?
Inductor.
Only inductor?
Yes.
Okay. So inductor will be there in series arm. Now next, in the constant K type low-pass filter, the capacitor is there in the shunt arm. But what about the M-derived low-pass filter? So both are present here, capacitor as well as inductor. So inductor is added because there will be the modification in the diagram already we learned, Z2 dash. Okay, so this is what the A part, that is called as what? T section of constant, sorry, T section of M derived filter. T section of M derived filter. Now next, I will draw the pi type and then we will discuss the value. So in the pi type, in the shunt arm, capacitor as usual. But in case of series arm, there will be the parallel combination of capacitor and inductor. Capacitor is added here in parallel with inductor. So this is what figure B, that is the pi section of M derived filter. Capacitor as it is ahead in the shunt arm, and instead of inductor only, the capacitor is drawn parallelly with or joined parallelly with inductor. That is the difference. So values will be now, anyone can tell what are the values now? Only M factor is multiplied. So L by 2 as it is. So only M you have to multiply. M L by 2. M L by 2. That's it. Okay. Now next, what about these values? So these value are M into C. Okay. And this is the what? 1 minus M square divided by 4M into L. So the values you have to check it. The names, what are the names of these component value? You can check it. Now here capacitor is there. So C by 2, C by 2. So only M factor you have to multiply. M C by 2. Okay. So here the value of these capacitor will M C2 by 2 already is there. So only you have to multiply M. So what about these inductor and capacitor? Only one inductor was there at initial stage. So L into M you have to multiply. So here 1 minus m square divided by 4m into C. So for this capacitor. Okay, 1 minus m square in bracket into C divided by 4m. So this is about what the values of all components in the T section and pi section. So we are going to discuss some points here related to M derived filter, and then we are moving towards the design of M derived filter. Okay, so we can start now. Consider T section. Consider the T section and pi section. Consider the T section and pi section of M derived low pass filter as shown in figure. As shown in figure above. Okay, now next for T section, shown in figure, for T section shown in figure A म्हणूया. The shunt arm is to be chosen so that or such that हे असं व्हॅल्यू आपल्याला घ्यायचे शंट आर्म मध्ये such that the resonant frequency f alpha. Okay, resonant frequency instead of fr we are giving the name as f alpha. Okay, resonant frequency f alpha of the series resonance, because this will form the series resonance circuit. No, because L and C are connected in series, such that the resonant frequency f alpha of series resonance circuit should be greater than म्हणजे या हा जो सर्किट आहे that will form what resonant circuit. I will write here. So this will form what resonance circuit, series resonance circuit having resonant frequency as f alpha. So is to be chosen such that the resonant frequency f alpha of series resonance circuit should be greater than which value? Anyone can guess? Yes, greater than what? Greater than which frequency? So this is what this filter is what? Which filter it is? High pass, low pass, band pass, band stop.
Low pass filter.
Yes. So for low pass filter, how many cutoff frequency will be there? Only one, na?
Yes.
So should be greater than cutoff frequency. Cutoff frequency, that is FC of low pass filter. So how many frequencies are there here? One is f alpha, that is the resonant frequency of shunt arm in the T section, and fc will be the cutoff frequency of this M derived low pass filter. If you are considering the pi section, what will be the word will change? The resonant frequency for the pi section, the shunt arm, instead of shunt arm, it will become series arm. The series arm is to be chosen such that resonant frequency f alpha of parallel resonance circuit should be greater than cutoff frequency of LPF. That's it. If you are considering as a pi section. Okay, so any section you can consider. Okay, T section or pi section, it is applicable. So the derivation will be there. We can discuss it. Up to this point, anyone having any questions, doubts? If it is there, you can ask. Okay, so we can start now. at a resonant frequency, at resonant frequency f alpha, at resonant frequency f alpha, what is the condition? XL is equal to XC. Okay, so XL value is what with respect to T section? L value, XL value is, anyone can tell? 1 minus m square divided by 4m into L, that is the L value. Okay, next omega value. Okay, JJ will get cancelled, so that will be the omega. But at omega with frequency, that is resonant frequency, that is omega alpha I will write. Okay, E is equal to 1 upon XC means what? 1 upon omega C. So omega is replaced by omega alpha, and C value is nothing but m into C, capacitor value. Okay, now this m and this m will get cancelled. Omega L, omega alpha, you can take in the left hand side, that becomes omega alpha square is equal to, remaining all those things you can make in, convert it into right hand side. Okay, so 4 goes to the numerator here, 4 divided by 1 minus m square into L into C. Now next, take the square root on both hand side, it becomes omega alpha is equal to 2 divided by 4th square root together 2. So under root 2 divided by under root 1 minus m square into L into C. Okay, now what is omega alpha? That is nothing but 2 pi f alpha is equal to 2 divided by under root 1 minus m square into L into C. So this 2 and this 2 will get cancelled. So f alpha will be 1 upon pi, you can take in the right hand side, pi into under root 1 minus m square into L into C. So this is what the equation of f alpha. This is what the equation of f alpha. Okay, so up to this one we can consider as the equation number 1. We are going to consider as a equation number 1 here. So once again read everyone what we discussed. So we are started the m derived low pass filter. So what are the changes in the diagram? You can observe it. What are the changes in the names of those elements which are present in the m derived low pass filter? You can observe it. So consider any section. So we are considering as a T section here. So in that there will be the modification in the shunt arm. So we have to choose such that the resonant frequency f alpha of that series resonance circuit should be greater than cutoff frequency of low pass filter. म्हणजे तो असं सिलेक्ट करायचं की त्याचा जो फ्रिक्वेन्सी येणार आहे रेझोनंट फ्रिक्वेन्सी त्याची व्हॅल्यू लो पास फिल्टरच्या कट ऑफ फ्रिक्वेन्सी पेक्षा जास्त पाहिजे, तेवढी काळजी घ्यायला पाहिजे. सो ऍट रेझोनंट फ्रिक्वेन्सी वी आर पुटिंग अ कंडिशन to find out the expression of resonant frequency f alpha. So we have given as a equation number 1 here. So after that we can continue. Now next point, but for low pass filter, the cutoff frequency given by, okay, but for low pass filter the cutoff frequency given by, what is the equation? FC value for low pass filter, anyone?
One upon
So that is equal to FC is equal to 1 upon pi into under root LC. FC is equal to 1 upon pi under root LC. So that you can consider as equation number 2. So this is the general formula for low pass filter. Okay, FC is equal to 1 upon pi into under root LC, which is made up of L and C. Now equation 1 and equation 2 are with you. So put this value 1 upon pi into under root LC that is present in the equation number 1. So put this in equation number 1. We get, so what we are getting, F alpha is there in the left hand side. So 1 upon pi into 1 under root 1 minus m square into under root LC is there. So I will put here, okay, 1 upon pi into under root 1 minus m square into under root LC. That's like, so 1 upon pi into under root LC, that you can replace by FC here. So that is FC divided by under root 1 minus m square. So this will give the F alpha. काय केलं समजा, 1 upon pi into under root LC, that is replaced by FC. So that comes in the numerator. So FC divided by this under root 1 minus m square remains as it is. So this is what my equation number 3. That is what F alpha. Are you getting my point? So this is, we got now expression of F alpha in terms of cutoff frequency and m value. So how to get the m value expression? M चे expression मला मिळवायचे. How to get? How to get? So from equation 3, under root 1 minus m square you can take in the left hand side is equal to FC by F alpha. Okay, F alpha take in the right hand side and under root 1 minus m square you can take in the left hand side. So take the square on both hand side. It becomes 1 minus m square is equal to FC by F alpha whole bracket square. So m square you can take in a one side. So it becomes what? 1 minus FC by F alpha bracket square is equal to m square. So again, you can take the square root on both hand side. Take square root on both sides. So you can get m is equal to under root 1 minus FC divided by F alpha bracket square. Okay, so this is the final expression to calculate the m value. So this is the equation number 4. So F alpha you can calculate based on the cutoff frequency FC and m value. If m value is given and FC cutoff frequency is given, you can calculate the resonant frequency F alpha. If cutoff frequency and resonant frequency are given, you can calculate the m. Okay, so out of 3, they will give 2. You have to find out third one. That is the important things. So once you get the third one, then you can find out the value of L and value of C. So we are moving towards the next point. That is the design of m derived low pass filter. So for that we require 3 important formulas. Anyone can tell important formulas? So first of all is here, that is m. If m is not given, then you can use this formula to calculate. So m is equal to under root 1 minus FC divided by F alpha bracket square, where FC is what? Cutoff frequency of low pass filter. Cutoff frequency of low pass filter, and F alpha is resonant frequency. Now next, second formula for calculating what? L and C. So for low pass filter, what is the equation of L is equal to? It is remains same compared to constant K type. So L is equal to K upon pi FC. Yes. So C is equal to, just take K down, 1 upon K into pi into FC. Formula same असणार आहे, low pass filter, constant K type आणि m derived filter. Only there will be the change in the value of here. Okay, m value. So these are considered as same as of as that of same as that of constant K type low pass filter. So these three formulas will require for the design of Young derived filter. So once again read it. I will give the 30-second everyone. You can read it, and after that we can discuss. We can solve the numerical example. Okay. Any questions? So these formulas we require the L and C value. How to calculate? So by using the formulas which we are using for constant K-type low pass filter, only M formula you have to remember. But the diagram is important. Many students are forgetting the diagram. They are not able to draw the T section and pi section. But if they are drawing the diagram, they are mentioning the wrong names. So it all matters. To get the full marks for such type of design problems, you have to give each and every value correct. You have to mention each and every component value correctly in the diagram. You have to draw the diagram correctly. You have to calculate all those things in a correct manner. Then and then you can get the full marks for such a design problems. Okay, so we are solving the first example here. Question number 1. The question is design M derived low pass filter having cutoff frequency of 1 kilohertz, comma, design impedance of 400 ohm and resonant frequency of 1100 hertz. So this is what the question. Design M derived low pass filter having a cutoff frequency of 1 kilohertz, comma, design impedance of 400 ohm and resonant frequency of 1100 hertz. So how to start now? From where we have to start? Yes. What are the given things? You can note down. First, you can note down which filter we are going to design. So we are going to design M derived low pass filter. Okay. So what are the given things? You can note down. What is the K value? Design impedance म्हणजेच काय? K value. So that is given as 400 ohm. Next, cutoff frequency means which value they have given? FC or F alpha?
FC.
Yes, FC is given as 1 kilohertz. So 1 kilohertz you can note down, or you can write as 1000 hertz. Next, resonant frequency is given F alpha. So that is what? 1100 hertz. That is what 1.1 kilohertz. So here you can check the resonant frequency value should be greater than cutoff frequency. Whether it is there? Yes or no? Resonant frequency is 1.1 and cutoff frequency is 1.0. So there will be the 100 hertz difference is there. So F alpha is greater. Obviously, it is follow the rules of M derived low pass filter. Now next, we are going to start first calculation part. So M value is not given. So M value we can calculate because we know that FC and F alpha. So that formula we can use. M is equal to under root 1 minus FC by alpha square or F alpha by FC square.
FC by F alpha.
Yes, which is less, you can mention in the numerator. FC by F alpha bracket square. Now, many students are making mistake here. They are using here F alpha divided by FC and they are getting value of M greater than 1. जर तुम्ही F alpha divided by FC जर केला तर तुमचं व्हॅल्यू M चा 0 पेक्षा 1 पेक्षा जास्त. मी तर तुम्हाला सांगितले की M चं व्हॅल्यू हे 1 पेक्षा कमी असायला पाहिजे. मग तिथंच तुमचं आन्सर चुकलंय का फॉर्म्युला चुकलंय ते तुम्हाला लगेच कळेल. Are you getting my point? If you are getting M value greater than 1 means I am doing somewhere mistake. Sorry. Okay. So M value should be in the range of greater than 0 and less than 1. That you can remember. Now put all those values of FC and F alpha and tell me the value of M. 1 minus 1K divided by 1.1K bracket square. So K will get cancelled. So M value is, anyone calculate and tell me. Fast.
0.41659.
Yes, so it is 0.416 to 42. So no unit, it is a constant value. So it is 0.416. Everyone is getting same one? Same
Yes,
answer
sir.
you are getting? Okay. So second one, we are going to design the L value and C value. So for low pass filter, so formula to calculate the L value is L is equal to K upon pi FC. So K is 400 divided by pi into 1 kilohertz. Calculate and tell L value.
Zero point 12732.
0.127 Henry, or we can consider 127.32 millihenry. Okay, if you are taking in the numerator, it becomes milli. So you can calculate 400 divided by pi. That will use 127.32 millihenry. Now next, third one, for low pass filter, we can calculate the C value. So just take K down, 1 upon K into pi into FC. So you can write the value here. 1 upon K is what? 400 pi into 1K. Again calculate C value.
Zero point 79 microfarad.
0.79 microfarad.
Yes, 0.795 no?
Yes.
0.795 into 10 raised to minus 6. That is nothing but micro. 0.795 into 10 raised to minus 6. So 10 raised to minus 6 means micro. So we got all those values, M as well as L as well as C value. Now we have to draw the T section and pi section. Okay, so T section and pi section we have to draw. Now next, the T section and pi section M derived low pass filter are given by, so you can draw the diagram now. So T section, inductor, two inductors are in series here, in the series R. So here it is capacitor and then inductor. In the pi section, inductor and capacitor are connected in parallel in the series R. And in the shunt arm, the capacitor value is there. Now you can mention the values properly. Many students are making mistake here. This is T section. This is figure B, pi section. So this is what the M derived low pass filter. M derived low pass filter. Now values you have to mention. So I will write the names first of all. Anyone can tell what are the names. In the series arm, L by 2 is there. Just you have to multiply M. M L by 2. M L by 2. Here C already is there, so multiply just M. So it will be for inductor 1 minus M square divided by 4M into L. Similarly for pi section, this is C2 by 2 already is there, just multiply M. M C by 2. Sorry, C2 I have used, no, just C. M into C divided by 2. M into C divided by 2. So for inductor and capacitor, already inductor is as it is, so just multiply M into L. So this is what 1 minus M square divided by 4M into C. So once you are mentioning, the next task is what? You have to mention the values of all these M L by 2, M into C, 1 minus M square divided by 4M into L, then M into C by 2, then M into L, and all those things you have to calculate and you can put the values. So one by one you can start the calculation and tell me the value. First of all, M into L, you can tell L value and C values are there, M value is also there. So just calculate each and every part. M into L calculate करा, त्याच्यावरनं ML by 2 येते. So M is 0.416 into L value is 127.32 milli. So that will use what? 52.96 millih. So that I will put here. 56.92 millih. Okay. Next ML by 2 is required here. So just make it half. ML by 2. So that is equal to 52.96 millih divided by 2. So that is 26 point something, that is the 48.
48.
Okay, 26.48. So you can mention here 26.48 millih. 26.48 millih. Okay, now next thing you can calculate. Next thing, M into C you can calculate. M into C, because after that M into C divided by 2 we requires. So M is 0.416 into capacitor value is 0.795 micro. So M into C is
0.3307.
Yes, 0.33 microfarad. 0.33 microfarad. So that you can mention here. 0.33 microfarad. Next, anywhere required? No. Now next calculate, we require M into C divided by 2. So 0.337 micro divided by 2. So that will give what? 0.166. 163, 165 च्या आसपास येईल. Yes or no?
Yes, sir.
Okay. 0.165 I will take microfarad. So that I will mention here. 0.165 microfarad. 0.165 microfarad. So 4 values I have calculated now. So what are remaining? 1 minus m square divided by 4m into L. 1 minus m square divided by 4m into C. So 1 minus m square divided by 4m into L you can calculate and tell. Put the values of m, L and calculate. Hmm.
63.2731.
63.27, correct. So that is about what? 63.27 millihenry because it is inductor. Now similarly calculate this last part. 1 minus m square divided by 4m.
50.302.
9 capacitor. Anyone got the answer? Anyone? Yes. Anyone? No one has calculated? Everyone are in hurry of attendance.
Sir, 0.7120.
0. Point.
712.
Mhm.
0.39.
0.3950.
0.395 आले का?
Yes, sir.
Yes.
Yes, sir.
That is correct. So it is 0.395 microfarad. So that is the correct. 0.95, 0.395. That is the correct one. Okay. So such type of design problems they can ask in the examination. So if any question will be there, you can ask. So in the next lecture, we are going to discuss about EM derived high pass filter, and we are going to solve the numerical example based on that. And after that, we are discussing the advantages of EM derived filter over the constant K type, so that we can complete the EM derived filter. And after that, we are going to start the attenuator part. Okay, so we can stop for today. Thank you, everyone.